Welcome to my video tutorial on how to create a dApp on Archway Network. This is what we are going to create, some simple chat. I'm going to connect my Kepler wallet. And here is the chat. Here already some messages, and let's try to add one another. Click post message, message is posting, approve, and we are waiting while it will be included into the blockchain. Okay, so here is our message. This tutorial will contain of two videos. First, we will create smart contract, and then front end, which you can see here, to interact with the smart contract. So typical dApp development contains of two steps. First, we need to code smart contract, deploy it onto the chain, and then we can interact with that smart contract with command line interface. But that's not convenient for our end users or customers, so we need to create some kind of user interface for them. It can be some website, like in this case, or you can create some mobile application. That's up to you. So in this video we will be creating smart contract. As a starter, we are going to start with Archway increment dApp template and then edit it to get our chat. So let's get started. I am already connected to my remote server. I have the Ubuntu installed latest stable. I am using Hetzner cloud provider. As you can see, it's pretty affordable and it's highly convenient and stable. Though there is not a lot of locations, but still. So if you are suffering with your cloud provider or did not choose one yet still, you can try Hetzner, and in the video description you will find my referral link and you will get 20 euros for start. Okay, let's get into it. First command, we need to create a wallet. We need to create an account with which we will be deploying our smart contract. I'm going to name it, let's name it demo. Need to enter keyring passphrase. Okay, so here is my wallet. I'm going to store it somewhere. Okay, and then we are going to create our template, Archway new. Okay, how would we name this? Let's name it Archie the chat. You can name it absolutely randomly, it's totally up to you. Yes, I want to use starter template, and yes, it's going to be in increment testnet Tori. Okay, waiting while it's creating our template. Okay, so it's created the project, and it also created this folder. So let's get into that folder. And I'm going to connect to this server with Visual Studio Code. I have extensions that allows me to work on remote server just like on local server. So connect remote, okay. So it's going to be root and allow access and password. Okay, and let's open a folder. Archie the chat, okay. Okay, so we are connected, we are in our project folder, and this is the structure. You can see here some Rust boilerplate stuff, config.json of our smart contract, and we will be working in the source directory. Here are several files, state.rs, and here is the struct that will be holding our smart contract state. Then here is message.rs file. In this file, the messages are described that will be used in our smart contract. So basically, there are three types of messages. Smart contract messages can have instantiate message. It executes only one time when you are deploying your smart contract. Execute message when you are doing some stuff that changes the blockchain. It actually can have several different commands or options, but there's going to be execute message and query messages that are the messages that are getting the smart contract state. They are free, no need to pay for gas because you don't change the blockchain state. So here are them. Execute message, it can be increment for our increment example or reset. Query message get count, so it returns current count value, and instantiate message, you can instantiate when you deploy in the contract your initial state, initial count variable value. And contract rs is the file where all magic happens. So what you need to know is that it as well has 3 entry points. Like we had 3 message types here, we have 3 entry points here: instantiate entry point, execute entry point, and query entry point. So we are going to edit these entry points, change messages to be what we need, and of course to store chat state we need to extend this state thing. And one another useful thing is schema folder, and here you can, for example, find what you need, how to interact with your smart contract. For example, here you see that you can pass there some JSON with increment property. For example, to instantiate message, you are going to send JSON with count, and some integer must go there, so that's going to look like this. So this will be your instantiate message. And there is a command, for example, cargo schema, that will automatically generate schemas for your smart contract after you do all your changes. Okay, let's get into this, and let's start with the state rs file. Oh, but first let's make sure that we have workable smart contract. So let's check some commands. Where is that? Deploying. No. Requesting test file. Okay, here let's try to execute Archway Build. So I am going to run here a terminal. Okay, it's already built. Let's run tests. Okay, here are 3 tests and they went fine. The tests actually are placed here. So function increment, reset, and proper initialization. So here are them. We will be changing tests as well, so make sure that our smart contract on the chain will work as expected. So I can close the terminal for now, and let's get back to our state rs. So how are we going to store our chat? I would suggest to have some struct for singular message, and then to store messages in a vector. So let's create that. Let's get this as a starter, and here will be message, and it's going to contain our actual message, and it's going to be string. Then as you can see here, it would have Monica. So let's add that as well, Monica, and that's going to be a string as well. And let's have actual address. Oops. Okay, like this, and here we would have then our chat, or I would name it just messages, and that's going to be vector of our messages. Okay, so I think that's pretty it for the state rs. And let's get to our messages. Here, instead of count, we would have message, string, and Monica. And the address we will get automatically from some how to say, from some environment data. Okay, execute messages. We would have only one message for post message. So let's name it post message, and it's going to accept the same stuff, just like this. Okay, what we are going to query? We are going to query our chat or messages, so let's name it get messages, and it's not going to accept any arguments because it's going to return all the messages. And get messages returns the current, let's just say the current chat. And response, what is going to be response? Response is going to be our vector messages, and it's going to be vector of message. Okay, just like this. I'm not importing here message struct or something else. We are going to do that when we will be compiling our smart contract. Then the compiler will tell us what we are missing and what to do. So let's go to our contract rs, and let's start with instantiate entry point. So each entry point accepts some boilerplate stuff like dependencies, some mutable dependencies, environment, and message info. And as you can see, message info contains sender information. So this is when we will be getting the address of our message poster and the actual message, which is different for each our entry point. So here we have instantiate message for instantiate entry point. And as you can see, it creates here the state. Oh, first it can return some response or contract error. And contract error is described here, so you can extend it if you need. Okay, so it creates state here and then saves the state and returns some response. So let's edit it for our needs. So owner, we leave owner as it is, and let's go to state and see what our state is going to contain. It's going to contain messages, and so here are messages, and let's create our messages. As you can remember, it's going to be some vector. I'm going to use a macro for creating vector, and here is going to be our chat message. And let's create that structure. Let chat message equals there is no need to write struct. We just create message, and it's going to contain a message. So this is going to be MSG messages, MSG message, and this is going to be MSG moniker and address. Let's grab from here. Actually, it's address, Cosmos std address, but we would have here string, so that will be a wrong type. Message info. Let's check this. Okay, so string. Okay, sender is the canonical address, and here is toString. And it's going to be called like this. So instead of clone, we should have here toString. Okay, that's it for Instantiate Message. Let's get to execute. So when executing, we would have only one endpoint, and it's going to be messages post message, and it's going to pass two arguments, message and moniker, and here our function will accept instead count, message and moniker. Okay, try increment we can remove, try reset, let's rename to try add message, and it's going to accept message, which is string, and moniker, which is string as well. Okay, that's looking good. State update. Okay, here is some checking, so only the owner could do this thing. We don't need this. And here we would state messages, and messages is a vector, so push there another message, let it be new message, and actually here you see we don't have count toString. Let's just remove this thing. Okay, so push new message, and let new message will be okay. I believe I here missed that. Okay, so here we pass right into the function message and moniker, so we don't need this, and we still have info, so this part will be fine. New message, push new message. Okay, looking good to me. Entry point library. Okay, So we can proceed to our third entry point query, and okay, it does not accept any arguments, just query message. Query message has entry point get messages to binary query count. Let's rename it to query messages, and okay, load state, and here instead of count we would return, let's say, messages and state messages. Okay, so it returns this. Looking good to me. And let's get to our tests. So the first test is about proper initialization. So this creates some dependencies we can play with, and instantiate message is going to be something like message string from, let's say, hello moniker me and address. Where is my address? I created, here it is. Okay. Actually our initial message does not contain address because it's getting it automatically. So creator, okay, instantiate. Okay, this is about response that it contains some messages. Okay, so let's query the state. Okay, get count. Here we query message get messages value count response. You see, we even did not rename this, so it's going to be chat response, and here as well chat response, and our value should contain messages. That's a vector, so first element of the vector and message, and that message should be this. Okay, so this is what it will be checking for. So in our storage first message should be this, and then for moniker it will be fine as well. Okay, another test, and it's going to be post message test. Instantiate message is going to be like this, for example, another hello. Okay, instantiate execute message post message and post message with these values. So we okay, so this is instantiate message, and another one is execute message. Execute, okay, should increase counter by 1, should add one more message. Okay, get query message get messages and value chat response from binary. And here will be something similar, but it will be first message and it should be equal to another hello. Okay, we don't have reset, so that's it. We will have only 2 tests. So let's try to build it. New terminal. So how do we build? Archway Build. Yeah, here going to be a lot of errors, but we will resolve all of them one by one. So what does it say? Expected identifier. Contract RS 22. Sorry, just copy paste it. And made a mistake. Here as well. Okay, let's try to compile this one more time. Unnecessary visibility qualifier message RS 14. Okay, it's already here. Accept it. Import create message unresolved count response. Of course. Count response. So instead of count response, we import in chat response, and here count response as well. Chat response. Okay, that's it. Cannot find struct message in this loop, so not found. Consider importing this struct. Okay, contract RS. So let's just put it here. Cannot find value mnemonic in this scope. Contract RS 54. Moniker. Mistyped it. Cannot find time message in this. Okay, now we need to import message into the message, and here is the snippet. Okay, should be good now. Struct message has no field named Monica. Struct message. It's here. Start message. Mistyped it here as well. No field message on type state message 58 state messages, because it's messages. Okay. Struct message has no field named Miniker, of course, because it's Monica and it's contract 23. Monica. Holy moly, it's compiling. It's compiled. Should have a snake case name. Okay. And let's do our tests. Yeah, we passed our test. So we can deploy our smart contract to the chain. Okay, requesting test funds, producing WASM executables. Okay, so let's make sure it will generate COSM WASM executables by just dry run, because without dry run it's going to take a lot more time. More time is going to take. A lot more time. It's already taking some time, but okay, almost done. Yeah, so we can deploy it. I am going to use my demo wallet. I created it earlier and I need to fund it with some coins. So send to my recipient. Let's send half of Tori, and yeah, I think that's it. Approve. Transaction is pending. File it. Let's try one more time. File it again. What our smart contract optimized was binary built successfully. From which wallet? Okay, I indeed need to find my wallet. Recipient. Let's increase gas. Sorry for this. Yeah, now it succeeded. So I can write here demo. Keyring passphrase, let me enter that. Okay, so confirm, yes for confirm. Will be it included into the blockchain? Failed. Yeah, sometimes it requires us to try several times. Okay, again try to confirm. Oh, it's deploying. Okay, Archie Arch's chat 0.1.0 is okay with me. JSON encoder for contract transaction. For us, it's going to be something like this. Message. Hello. Let's just do without this stuff. And moniker dev. Okay. Enter keyring passphrase. And one more time. And yes. Waiting 6 seconds. Again. Should go through this process again. Confirm. Yeah, sometimes it's pain to deploy a smart contract, but with interaction it will be easier. Sometimes it's working better, sometimes worse. Successfully instantiated contract with address on transaction hash. So I would store this information so I can use it later. Definitely I will need smart contract address, and they recommend us to set metadata. Let's do that. Send transaction from which wallet on your keychain. Of course, that's going to be demo. Developer address which can change the metadata. I'm going to insert the same address. Enter for rewards as well. Premium rewards, no. Use the contract rewards for gas rebates to user, no. And our passphrase. Hopefully the latest time. Confirm transaction. Yeah, successfully set contract metadata on transaction hash. So that's it, our smart contract is created. So let's query its state. So we should have there one message interacting with your smart contract. So let's use this command, but I'll update this for our case. So instead of get count, I believe there are get messages. Yeah, get messages. You see here we have such naming, but because of this directive, it will be changed to snake case. So that will be like get messages. Okay, let's try this. Incorrect address length. Success. You see, Archway CLI is a wrapper for Archway binary, and it does not work well sometimes, so let's use it just like it proposes us here. So here address of our smart contract. Let me get that. And query. This is the query. Let's try this command. Hopefully this is correct. Yeah, so we have messages, message address. This is automatically added, hello and dev. So let's try to add one more message. For that, we would have not get messages, but let's see, post message, and here will be message, another hello, and moniker sample. Okay, let's try this. Something is wrong. Invalid request, get messages. Invalid argument, error parsing to type, Archway the chat, message query message, unknown variant, post message, query message, post message, post message. And what's wrong here? It's query. So that's going to be transaction. So it's going to be Archway transaction. Okay. I don't think it's going to work out, but it would say us what is, how to use it. Send transaction from which wallet, demo, and my passphrase. Okay, confirm. Finally to execute, but translating it to the command for binary. Okay, so this is what it's going to be. Transaction query execute. I did not copy it properly. Execute. Received one argument usage. Execute. I missed contract address. Execute. Empty address string is not allowed. Contract JSON send args. It seems like it expects we pass address string, but that should be taken automatically. execute message, message moniker try, message moniker, message moniker address, new message. It's looking fine to me. Message moniker, message moniker. Execute message, post message, message moniker, empty address string is not allowed. Let's try to add from flag, from which address. From demo. Okay, something is going on. But did not work out. Chain ID requested but not specified. That's better. Let's add chain ID. And how to do that? Can you see chain ID? Chain ID. Chain ID Tori. Confirm. Yeah. Signature verification filed. Please verify account number and chain ID. Chain ID Tori1 and passphrase. We are close. Yes. Now our transaction is successful and we can get our state one more time. And we have here now even 3 messages. Okay. But yeah, now we have working smart contract on Archway Tori chain. One thing I missed is to produce schemas. So let's cargo schema it. On isolate import Archway the chat on schema rs. Where is that schema rs? Examples schema rs, and here is chat response, and let's try it one more time. Clear and cargo schema. Chat message should have ethnic case, cannot find time count response. Count response, instantiate, execute query state and instant of count response. We are going to have chat response. Okay, so it removed some files and created a bunch of files. So our state now is looking like this. execute message. So why do we need this? If somebody will be creating a front end for your dApp, he does not or she does not need to know Rust language. That guy can just go to schemas and see here how to interact with your smart contract. So execute message is going to be post message, and then we'll have two fields, message and moniker of string. So just like we did here. Okay, so that's it for this tutorial. We'll be happy to see you in my next tutorial on how to create React frontend for this smart contract. Bye.